Good morning, student. Let's do our chapter nitric acid. In nitric acid, first we completed a laboratory preparation and a large scale preparation that we completed. I hope you understand all of that thing. Now let's learn the physical property of the nitric acid. So in physical property, first is color. So as I told you that nitric acid is colorless, but if it is pure form, purest form 98% is pure form, then it is a colorless. Otherwise the commercial scale, which is a 68% concentration, which is in yellow color or brown yellow color. So why the brownish yellow color? Because of the nitrogen dioxide, because of the dissolution of the nitrogen dioxide present in the HNO3. So that's why it is yellow in color. Okay, so you have to know about and you have to remember this thing, student. When the nitric acid, if it is a colorless solution, then it is a purest form, 98% is there. But if it is in yellow color, which means that the concentration is less, or NO2 is already dissolved in it, or that is a 68% solution. Okay. Now the odor or smell of the nitric acid, that is a suffocating odor, very bad smell coming out from the nitric acid, you cannot tolerate it. Then the taste of the nitric acid, it is an acid, so definitely the taste is a sour taste. Okay. Then a density of the nitric acid, if it is 98% of HNO3, then the 1.5 gram centimeter cube is a density. But if it is a 68% HNO3, then the density will be reduced. Why density will be reduced? Because the water part present in it. So if the water part present in it, the density will be reduced, that is a 1.42 gram per centimeter cube. So this is the density according to concentration wise. Then the solubility of the nitric acid is highly soluble in water. It can dissolve when we add water in it, immediately it will dissolve in it. Then the boiling point of the nitric acid, that is 86 degrees centigrade, and the freezing point, that is of minus 42 degrees centigrade. That much only you have to know. This is not that much of important, but this two thing beginning these points are very important. Then the physiological nature means that how in nature wise it behave. So we can say that it is non poisonous, but it is very corrosive in nature, which means that it will if we open the bottle of the nitric acid, you will find out some fumes are present on the upper layer of the nitric acid, so the little bit corrosive it is. Okay. So that corrosion present on the nitric acid, and if it is if the one drop of the nitric acid is drop in your skin, so it will very painful thing, and we will feel that very painful blister on your skin, and the stain of yellow color stain will be coming on your skin. Why the yellow color coming? Because the nitric acid is react with the protein on your skin. It is react with your protein. The skin have its own protein. So the nitric acid is react with the protein of the skin and form a xanthoprotic. It will form a xanthoprotic. It will form. So and that xanthoprotic is that compound is yellow in color. So that yellow color stain is arise on your skin if it is drop on your skin. So it is very painful. Okay. So that is a physiological nature of the nitric acid. The same thing happened with the concentrated H2SO4 also. The concentrated H2SO4 is react with the skin protein, and then the yellow color skin will be yellow color stain arise on your skin. So that thing happening. Okay. So these are the physical property of nitric acid. Now let's do the chemical property, very important, student. So much important as an exam point of view, number of question asked from this. So it is you need to learn about that. The first chemical property of the nitric acid, that is a stability. Stability, how much stable it is. So if we take a 98% of nitric acid, So it is unstable towards heat, which means that suppose that I have a nicely colorless glass, or we can say that very transparent and clean glass bottle I have, and this is the bottle suppose, and nitric acid if I fill in it and store this nitric acid into the cupboard, and if the little bit amount of the sun rays are coming in that cupboard, or if it is openly place it is put, so little bit amount of the sun rays is coming, then it is immediately decomposed, which means that the smaller amount of the heat, even if it absorb, it will immediately decompose, and if start to decomposing and convert into the yellow color. So how it is decomposing and converting to the yellow color? So here is the reaction. When the nitric acid is little bit heated, this NO2, nitrogen dioxide, will be produced, and that nitrogen dioxide is one more time dissolved into the HNO3. And when this nitric acid, because you know that nitrogen dioxide is a brown, yellowish brown color. So when it dissolves into the one more time in this water or in HNO3, then it convert into the yellowish color. So that's why we can say that the nitric acid is unstable towards heat and turn immediately yellowish in color. I hope you understand this thing. So here the decomposition reaction, you can see that if we take a nitric acid little amount, 1 ml or 2 ml in a test tube and heat it, so you will find out that a brown color, very dark brown color fumes will coming out, and that is a nitrogen dioxide. So that is a decomposition reaction. And same thing is very less amount of heat if we get, then also it is convert into the yellowish color. What reaction happening? This reaction is happening. Okay, I hope you understand the stability, very important student. Now the next one, that is acidic in nature. As you know that if the any acid when dissolved into the water, it convert into the hydronium ion. Same thing happen with the HNO3. When HNO3 dissolve into the water, it convert into this hydronium ion, and that hydronium ion, this is the hydronium ion, and free hydronium ion impart acidic character. Free, because what happened that when the HNO3 dissolve into the water, this hydronium ion and the NO3 minus, both of them are freely to move into the water, and when the both of them free to move into the water, and this hydronium ion is impart the acidic character. So we can say that HNO3 is acidic in nature. That's why its taste is a sour taste. Okay, I hope you understand this thing. So now let's learn the next chemical property, action with indicators. So if we see that here, the action with indicator, so the first with litmus paper or litmus solution. That's why I just wrote here the litmus. You can take a paper or you can take a solution, both you can take. So the blue litmus paper turns red, right? That is the first one. Or blue litmus solution turn red, that also happen. Second point, a methyl orange, which is orange in color. Methyl orange, which is orange in color, that orange turns into the pink color. And the colorless phenolphthalein. Phenolphthalein is a colorless solution, student. Phenolphthalein is a colorless solution. When you add the one drop of the phenolphthalein into the HNO3, it will convert into the pink in color. Okay, so this is the action with the indicators: litmus paper, methyl orange, and phenolphthalein. For all the acids, the same thing happening. For all the acid, which means concentrated HNO3, and HCl, and acetic H2SO4. Okay, so all of them are giving same reaction with the indicators because they are acid. Okay, next one. Next property, that is action with the metal oxide, which means that metal oxide, any metal oxide, that active metal series, as we know that, then the sodium, potassium move on, then the copper and all that. So that active metal series, if we take oxide of that active metal series, then it react with diluted HNO3. If the diluted HNO3 react with the metal oxide, it convert into the metal nitrate and water. Same thing. Okay, just same thing as we done in HCl. You have to do this same. Okay, so what happened, the metal oxide, this is K2O, this is metal oxide K2O, you can able to see it here. K2O when react with the HNO3 or convert into the KNO3 metal or potassium nitrate. Okay, this is the potassium nitrate and water will be formed. And if we move then the active metal series, so then copper oxide also give the same reaction. Okay, what the copper oxide will give? Let's write CuO, it convert into the H, when it react with the diluted HNO3, it convert into the copper nitrate KNO3 twice plus H2O. So, action with the metal oxide. Third one, action with the non-metal or metallic or non-metallic hydroxide. You can take metal oxide or non-metal hydroxide. Metal hydroxide or non-metal hydroxide, any you can choose. So, here this is the metal hydroxide which means OH. So, the metal hydroxide when react with the HNO3, it convert into the nitrate and water. Same thing here, but here the oxide and here the hydroxide. That's why here the we need to balance it. Here automatically it will balance, no need to balance. Okay, so same thing happens. So let's do with the copper. So with the copper, if we do, then the 2HNO3, because here the 2 hydroxide are there, so it will convert into the CuNO3 twice H2O. So if we move on to the active metal series from the potassium to copper, so any will come. That is not necessary that two reaction are giving in your textbook that only these 2 metal will come or non-metal will come. You know that metal series, so in metal series number of metals are there, as I told you, right? As I told you the metal series name and how to remember the name, that also I have told you, right? That Kedarnath ka Mali, yeah, Kedarnath ka Mali, I don't remember that. Kedarnath ka Mali aloo phika pakata hai, right? That is the one. So that you need to remember, and according to that any metal will come, and for the any metal hydroxide if you use, and it convert into this. Got it? So this is the way it is convert. Now the next one, the action with the metallic carbonate. So carbonate CO3, any metallic carbonate we can choose, and when all of this react with the diluted HNO3, not concentrated, not needed. Okay, concentrated HNO3 is not needed. Whenever the concentrated HNO3 needed, I will tell you. But here the all the chemical reaction are react with the diluted HNO3. Okay, so the carbonate, if the carbonate are there, as I told you in SCL when I taught you the SCL chapter, in that I told you that if the carbonate is there, then definitely carbon dioxide will be produced. Okay, so same thing happen here also. If you are you are getting a product here for the SCL, if we are using that K2CO3 plus SCL, if we use here like 2, then it will form 2KCl, okay, potassium chloride, and here nitrate. Here it will form what? Nitrate will be formed. The same thing happen. Another product H2O plus CO2. Okay, I hope you understand. Same reaction. You just need to understand. Don't no need to by heart all this thing. You just understand all this thing. If this thing asked in exam, you can write this. Okay, you just need to understand thoroughly. Then no need to by heart all this thing. Otherwise, it is very difficult for you to by heart all this thing. Practice, practice and practice. In chemistry only you need to do practice, student. Okay, whenever you are solving any question answer in chemistry, you have to write your answer in rough work. You have to do rough work. By writing only you can prepare chemistry. If you are reading, then it will you cannot able to memorize all this thing. This is my biggest advice to you, student. Every till 12th standard, everyone I am telling you, chemistry is those who feel that it is the very hardest chapter, hardest subject, but it is not. if you are practice like a numerical, if you are doing, when you are practicing numerical, then you can easily calculate all the numericals in maths. Same thing you have to do in chemistry. Exercise question answer, take all the question answer and solve it yourself first, then find out the answer from your textbook. Then only you can able to solve all the answer in exam. Otherwise, if you read it in exam, you cannot able to gain what I read. You cannot able to find out that what answer will come, because you haven't practiced. So all this chemical reaction, through the practice only you can do it. So solve all the question answer by self, by writing. You write every time, write it. Okay, don't read, write only. Okay, sorry, 2-3 minutes I took. Now let's move on. K2CO3 plus twice HNO3, so CO2 will be formed. Same thing till the active metal series copper nitrate, copper carbonate. If we do, then it will form a, here you can see the 2HNO3, it will give copper nitrate, CuNO3 twice plus H2O plus CO2, carbon dioxide. Okay. Then the action with the metallic hydrogen, carbonate. So here also the same metallic hydrogen is there, but the product will be same. Got it? Here diluted HNO3, this thing, and here the copper till magnesium. Here till going down to active metal series till magnesium, this reaction is happening, because the hydrogen is not, there. That's why. Okay, I hope you understand this point. So you read it, you solve it yourself. You took all the metals and react with the nitric acid. You take all the metal from the active metal series and react with the HNO3 and form a product. Then you will easily memorize all this thing. Okay, so that's one only. Now the next one, that is the action with the metallic sulfide, SO3. So let's, metallic sulfide when react with the nitric acid diluted, it convert into the metallic nitrate plus water plus SO2. Here instead of the CO3, here now SO3. So SO3 convert into the SO2. So the metallic sulfide, when the metallic sulfide react with the HNO3, it convert into the KNO3 potassium nitrate and water and SO3. Same you can do with the copper. So in active metal series still copper, it convert into the copper, what it will convert, diluted, it convert into the CuNO3 twice plus H2O plus SO2. Okay, gas, SO2 gas. So this is the way it will produce. I hope you understand this thing. So here all the reaction we have completed with the nitric acid. Okay, so these are the chemical action with the and the nature and the reaction with the diluted HNO3. Now let's learn a new thing, very important, oxidation property. HNO3 have oxidation property, which means that it oxidize other one. So it will reduce itself and oxidize other one. Why the HNO3 have oxidation property? So first see that when the HNO3 is decomposed, if we take a concentrated HNO3, it decompose into the H2O, NO2, and this is a nascent oxygen will be produced. When we take a concentrated HNO3 and decompose it, it will convert a nitrogen dioxide, water, and this is a nascent oxygen. And this nascent oxygen is unstable, okay. So it is unstable. Why it is unstable? Because it do not completed its octave. So it's ready to accept electron, because the oxygen have a 6 electron in outermost. So octave is not completed. So it's ready to accept electron. So immediately it will accept electron. And we know that the accepting of the electron, what is the reaction? So the next one accept electron, hence it make a nitric oxide, this nitrogen dioxide, nitric acid oxidizing agent. Okay, it will form a oxidizing agent. Okay, it is a reduce, it will reduce, HNO3 will reduce, it is a reduced, but it behave as a oxidizing agent. We learned this thing in 9th standard, student. Okay, so how it behave as oxidizing agent? This is the way, because HNO3 easily decompose. When it is decomposed, it convert into the nascent oxygen, and nascent oxygen easily accept electron, and accepting of the electron, which is called oxidizing reaction. Okay, so it oxidized, and when it oxidize, so it will easily oxidize with the metal. For example, the metal, any metal, and if the metal is come in contact with the nascent oxygen, it will react and convert into the metal oxide. I hope you understand this. Any metal, so it will any formula will come, M2O or MO2 or whatever. Okay, so this is the thing you do, M, which means metal. So this is the way it will oxidize other. So which one it oxidize? So the nascent oxygen oxidize metal, or it will oxidize non-metal. Non-metal also oxidized by the nascent oxygen. It will oxidize inorganic compound, any inorganic compound like carbon monoxide. Okay, and also carbon also, and then organic compound also. Organic compound also like a benzene and like a phenol or alcohol, all of them are organic compounds. So it oxidize all of them, HNO3. So when we want to do oxidation reaction, if we use HNO3, so it behave as oxidizing agent and oxidize metal, non-metal, inorganic and organic component. Okay, and the nitric acid itself reduce, as I told. Nitric acid itself reduce, and if it is reduced, the product will be formed like NO2 will be formed, or NO will be formed, or N2O will be formed. So how the why it is different, why not same? At different temperature and different concentration of the HNO3, it give a different nitrate form, NO2 or NO or N2O. If we take a particular temperature, we will get NO2. If we change the temperature, maybe we will get NO. If we change the temperature, maybe we will get N2O. So this is the way this product will be formed, oxidize. Okay, so it will reduce. Which one is reduced? HNO3 is reduced and nascent oxygen is produced, and that nascent oxygen is oxidized other metal, non-metal, inorganic or organic. So depending upon the concentration of the HNO3 and the temperature of the reaction, the product will be formed, that NO2, NO or N2O. Okay, I hope you understand this thing. If you cannot able to understand, if you can ask me after watching this video, student. It's very important exam point of view. Okay, very important. I will give you you can find out some question answer backside. Okay, now let's see that how it's oxidized non-metal. So first it oxidized non-metal. Suppose non-metal, carbon is a non-metal, that you know very well. Carbon is a non-metal. So when the carbon, you have carbon, you can take a carbon as a charcoal, you can take carbon as a carbon cake. Okay, so many way you can take a carbon. So the carbon, when react with the HNO3, here the concentrated HNO3 we are taking. The concentrated HNO3 we are taking. So concentrated HNO3 when react with the non-metal, it convert into the oxide, which means here you can see the carbon dioxide, CO2. So it convert into the oxide. Okay, or suppose it will take a sulfur. We will take a sulfur here. When the sulfur is react with the 6HNO3 concentrated, here concentrated, okay, we are using as oxidizing agent concentrated HNO3, not diluted, concentrated only. So the concentrated will be form a very nicely nascent oxygen. That's why concentrated HNO3 we are taking. Nascent in a diluted HNO3 have a water. So that's why we are not taking diluted HNO3. So here in concentrated, a very less amount of water is there. So higher amount of the nascent oxygen will be formed, and it will be very helpful to the oxidize other. So that's why concentrated HNO3 we are taking. So when the concentrated HNO3 react with the sulfur, it will convert into the H2SO4, which is called as a oxy acid. oxy acid. So we can say that the HNO3 when react with the non-metal, it convert oxides or oxy acid. Okay, for like example P4. So phosphorus when react with the HNO3, it convert here the 20, it convert into the 4H3PO4. This is phosphoric acid will be formed, plus 4H2O plus twice 20 NO2. Nitrogen dioxide always produce. Okay, so this reaction possible. If we take a phosphorus, not P4, only P, then the 5HNO3 if we take, concentrated HNO3 if we take and boil this solution, so it convert into the phosphoric, it will also produce a phosphoric acid and H2. If we take a less amount of the phosphorus, we require very less amount of the nitric acid, and then phosphoric acid will be produced, less amount of, and 5NO2 gas. I hope you understand this oxidation process, student, very important oxidation process. So in general we can take the metal react with the mineral acid to form a respective salt and hydrogen gas in oxidation reaction. If the metals, here we will discuss non-metal. So before we learn the metal also, when the metal is react with the mineral acid, which means which are the mineral acid? All the H2SO4, HCl, HNO3, the mineral acid to form a respective salt and hydrogen gas, which means that mineral acid like HCl, if we take a mineral acid HCl. Okay, so we'll learn in 9th standard, when the metal react with the acid, it convert into the metal oxide or metal chloride and convert an H2 gas. In hydrogen chapter we learned this. So there here it produces. But however, the nitric acid is a very powerful oxidizing agent. This thing we learn, but here this theory is not applicable. Why? Because acid, HNO3 is an acid, but it is a very strong oxidizing agent. So it is very powerful. HNO3 is a very powerful oxidizing agent. So that's why the hydrogen formed during its action with the metal reduce the nitric acid to produce such a nitrogen. So here what happened, that because of its powerful oxidizing agent, instead of the hydrogen gas it produced, this hydrogen gas convert the nitrogen HNO3 into the NO2 or NO. You can read that in your textbook. So the nitric acid is a very powerful oxidizing agent here. Now, nitric acid is a powerful oxidizing agent. The hydrogen formed during its action with the metal reduce the nitric acid to produce such a nitrogen monoxide and nitrogen dioxide. Okay, so that is why here this theory is not applicable for. That's why when we learn this hydrogen gas will be produced, there we haven't used HNO3, we use that HCl instead of the HNO3. Why? Okay, because of this HNO3 is more powerful reducing agent. Another one, the nature of the product of the reduction depend upon, which means that this NO2 or NO or N2O, which depend on a temperature as well as concentration. Okay, so this is the way we will learn. Now the next one, thus till here we'll do. The next thing, the action with the diluted nitric acid with the copper and action with the concentrated nitric acid with the copper, and the taste for the nitric acid, that I will explain you in a next video, or I'll send you a video. Okay, wait a minute, I'll send you a video like here. This two thing you read it yourself, you know very well. This copper when react with the HNO3 convert into the copper nitrate H2O and NO2. Here the both the way here nitrogen oxide is produced and here nitrogen dioxide is produced. Why it is? Because the amount of the we'll took here the diluted HNO3 and here the concentrated HNO3. So this is the difference. If we take a diluted HNO3, then the nitrogen oxide will be produced, and if we use here the concentrated HNO3, then the nitrogen dioxide will be produced. Okay, two things. You read this. Okay, now the test for the nitric acid. Here the test for the nitric acid, this two thing that you read. This, for this thing I am sending you a video link, animation video link, brown ring test. Brown ring test, very nice brown ring test that you will do in practical also. I will send you a animation video of this. So after watching this video, I will send you that video also, so you watch both of them, and then you read this use of the nitric acid. Okay, you read this use of the nitric acid. Then further the nitrates I will explain you in the next class. Okay, this next class I will, next week we will learn the nitrates, but till here you will read, you just read all the uses. I am sending you the video of this. Okay, you will learn all the detail of this, and if you find any query after watching that video, just tell me. I hope you understand all these things, student. If you find any difficulty, you message me. Okay, thank you. Have a nice day.